today I'm going to test out a fancy new current probe that I just got. So in the 400 car battery video, I had some issues measuring current. The main issue was just that I bought this no-name Hall effect sensor online, and it didn't quite perform to expectations, and it led to me to just taking one of the 40 cables of the main bank and feeding it through, measuring the current from that, then multiplying that value by 40 to get the total current. Which, it probably gives me a good ballpark, but it's not great. I want to do better than that. So yeah, I got this new Rogowski probe here that can measure to 300,000 amps. So I can put the full currents of the batteries through it, and it'll be good for some other high current experiments I want to do that don't use the batteries. Now these things are actually pretty simple. They're not even that hard to make. It's just that the main reason I didn't want to make one myself was other than being lazy, is it's just the calibration. So, I can produce these big currents, but I can't produce them precisely, and so I kind of wanted something that, should in theory just work right out of the box to produce, to give me the right measurements. And this thing was calibrated right before I got it, so yeah, I'm gonna test it out. So what I'm gonna do is I've got this single car battery here, and I'm just gonna short it and compare the values I get from the old Hall sensor and then this thing here. And if the numbers are reasonable to some extent, then I'm just going to assume that this thing is calibrated correctly, and I'll go stick it on the batteries then. So yeah, let's get started. Now, one thing that I do find funny is how all my test equipment is covered in burn marks. It's just my test equipment is used in a very unusual scenario, and yeah, it's just covered in all these little burns and even a little bit of bird poop from just being out in nature. So I didn't really bother to clean these leads, but it's not like I need the most perfect amount of connectivity here. Okay, now I've learned I want to short a car battery by wrenching across the contacts. But although I connected the entire bank, all 400, without accidentally, shorting with a wrench. So I thought that was pretty impressive, because I did short it a few times when I did the 100. Okay, should be good. Alrighty, let's try this out. So set this. I think I have it triggered at just 400 amps on the old probe then. So there we go. Okay, so something triggered. Now I gotta do the math. I don't know how to change like the axes on here, so it's just reading in volts, and then I have to figure out the current from the signal. Let me figure out how I should probably figure out if there's a way to do that, because this kind of sucks. I had to always do this with the car batteries too. So according to this, the Rogowski probe measured 2,500 amps, that's reasonable. And now we can also look at see that the voltage, so I was measuring the voltage across the battery, dropped to about okay, so it dropped to like 3.5 volts. Now that's pretty reasonable then. That's pretty reasonable. So that's the batteries did most of the dropping of the circuit. Yeah, I think that seems to make sense. Okay. So the purple line is battery voltage. The blue line is Rogowski currents, but of course there's a factor there, and then the bottom line is the Hall sensor, which is basically just noise. But that's how I used to trigger it. But so this one, the Rogowski coil reads, I think it's 0.02 volts for 1,000 amps. So it's like about 2,400 amps maybe with the peak currents there, which is yeah, that makes sense. Okay. So the reason why this didn't make much signal, it just made noise, was because it wasn't plugged in. It would help if I actually plug in the Hall sensor. It's hilarious that it's still triggered. Let's do that again with it plugged in. All right. Let's try that again, but with the Hall sensor plugged in. Hall sensor triggered. No, but now I missed it. Oh, I guess this little pulse now. Okay, this 30 as well. All right, so now for the math again. Figure out how's this one triggered. 400. These numbers match. No, they don't match. They do not match. Why don't they match? What? Wait, how's that one work? 520. So yeah, 250 millivolts should be a kiloamp. So yeah, that should be a lot bigger than that. That doesn't make sense. The old Hall sensor is measuring apparently too small compared to the Rogowski. All right, I'm not sure why these numbers aren't checking out. I'm inclined to believe the Rogowski coil because 2400 amps from short-circuiting this battery is very reasonable, and you can even see the voltage drop to about 3 volts across the battery terminals. So a little bit more than 3/4 of the power is being dissipated by the battery internal resistance. But yeah, so that's like a total circuit resistance of about 5 milliohms. So roughly 4 for the battery. That's absolutely in line with the extensive measurements I've done on these batteries. I can't figure out what's wrong with the old probe. I might be just doing math wrong. I have to think about this for a second. Son of a... That's it. That's it. Now let's try that again. I had the probe at 10x when it's really 1. Ugh, I'm really bad at electronics. Goodness, this is ridiculous. Yep, okay, so where's that? I gotta do the math again. But these should line up. 246. What's that? 1,000. Yeah, 24. Yeah, there it is. They line up exactly. 2400 amps. So, yes. So yeah, that's good. I'm ready to check this thing on the car batteries then. This also brings up another interesting point. So these car batteries, if they're fully charged and they're warm, then I measure a 3.5 milliohm internal resistance. So that actually implies that these batteries are capable of quite a bit more current than I'm actually pulling in my setup. The main limit is contact resistance of not like the switch or like the Yeet blocks. It's just the contact resistance of all the little connections. So people see this like here this battery has a 680 amp cold cranking amp rating and a 850 amp MCA. And so people think that these are like your limits here, but no, for like a short circuit you could produce way more current than these really restrictive test conditions. These are for like CCA is for like 0 Fahrenheit for 30 seconds without dropping below, I think, like 7.2 volts or something. I'm less confident about that one. So here I'm just briefly shorting it for just a fraction of a second, and so yeah, that you can get quite a bit of current in a dead short from a car battery. But yeah, it's too bad that all those contact resistances add up, because in theory I could be pulling close to 300,000 amps from my battery bank. So yeah, but yeah, so that's good. It just took me a bit to not be an idiot, but yeah, I'm glad to see that this works. Cool. Alright, I did figure out how to change the axes on this thing, at least for the most part. So now they're reading in amps, and it doesn't allow me to go up to really big numbers here, so I can't put in 4,000 amps per division, just 4 amps. So then, well, yeah, at least it makes the math in my head a lot easier. So now I'm just multiplying these by 1,000 as opposed to doing some stupid division by 0.0 something. I don't know. So yeah, so I'm better set up now. This will be easier in the future.